The first step for finding absolute extrema on a closed interval is to find the critical numbers or critical values for the function. Okay, so first you need to find the derivative of the function. Okay, so for this example, the derivative is 12x cubed minus 12x squared. Okay, critical numbers are where the derivative either equals 0 or where the derivative doesn't exist. Okay, so here's our derivative. We'll set it equal to 0. I'm going to go ahead and factor at the same time. So factor out 12x squared. You're left with x minus 1 equals 0. So the derivative equals 0 when x equals 0 or x equals 1. Okay, the derivative is a polynomial function. X is defined at every value for this derivative. There's no fraction or anything else unusual, and so the derivative always exists. So don't have to worry about this. So these are my two critical numbers for this function. Okay, so the next step is to evaluate both the endpoints and the critical numbers. And so the way we're going to do this is to make a table. Okay, so on my table, I'm going to put the endpoints in first. Okay, then I'm going to put the two critical numbers in to my table. If by chance any of these critical numbers were smaller than -1 or larger than 2, then I would just ignore those and not put them in the table. But both critical numbers are between the endpoints, and so therefore I'll put them both in the table. Okay, now realize that when you're evaluating this, I'm trying to find the y-coordinates, the highest y-coordinate and the lowest y-coordinate on the graph of the original function. Don't plug these back into the derivative. In fact, if I plug 0 and 1 into the derivative, it's going to equal 0. That's how I found them. Okay, I'm not plugging these into the derivative, I'm plugging them into the function. Okay, and so now I just take these one at a time and I plug them into the function. So f of -1 is 3 times -1 to the 4th minus 4 times -1 cubed. So that's going to be 3 plus 4, that'll be 7. Okay, I plug in 0. F of 0 will just be 0 minus 0, or 0. Okay, f of 1 is 3 minus 4, or -1. And f of 2 is 3 times 2 to the 4th, which is 16, minus 4 times 2 cubed, which is 8. So let's see, this is 48 minus 32. So that's going to be 16. Okay, and then I just need to state my answer. I'm trying to find all of, or both of the relative extrema, or absolute extrema, absolute max and min. So I'm going to say that the absolute maximum is, and you pick the highest y-coordinate, 16, and the absolute minimum is the lowest y-coordinate, which is -1. Okay, and that is my answer. Okay, just to verify, I'm going to show you the graph. Okay, so we can see over here, the y-coordinate at this endpoint was 7, the y-coordinate at 0 was 0, the y-coordinate at 1 was -1, the y-coordinate at 2 was 16, so therefore the absolute maximum or highest y-coordinate on the graph is 16, and the absolute minimum or lowest is -1. You have to have the table. The table is the work that justifies your answer.